Now we'll head into the final part of exercise 6J. So we've got to solve this equation here, and the trick is that we've got sine and cos on both sides. But what I have to remember is that tan x is sine x on cos x. So if I can divide each side by cos x, I'll get sine 4x divided by cos 4x equals 1. So that tells me the tan of 4x equals 1. So my base angle, the tan of what gives me 1, is the tan of pi on 4. So what happens is 4x is equal to pi on 4 is the first one. Now this time, if x is between 0 and 2 pi, 4x is between 0 and 8 pi. Or I can think of it as having to do 4 laps around the unit circle. So if you think about our answers, we're going to get 1 here and 1 here, and then we're going to go round 4 times, so we're going to get 8 answers. So pi on 4 is my first one. My next one's here at 5 pi on 4. My next one is here. Well, this is 8 pi on 4, because that's the same as 2 pi. So there's one at 9 pi on 4. Then I go round to here, and this is 12 pi on 4. So the next one is at 13 pi on 4. And we go around the circle until we get them all. So I've got 21. My next one's going to be 25 pi on 4. And then 29 pi on 4. So there's a lot. Now I have to divide everything by 4 to get x on its own. So I get pi on 16, 5 pi on 16, 9 pi on 16, 13 pi on 16, 17 pi on 16, 21 pi on 16, 25 pi on 16, and 29 pi on 16. And thankfully none of those cancel down. So that is my answer. And just remember, if we've got this 4 here, we do 4 laps, or we think of our changed domain. Right, so the next one's the same sort of technique. If you want to stop the video and have a go, I think that's a really good idea to see if you can use this same concept. So what I'm going to do first is divide each side by cos x. So I'm going to get sine 2x on cos 2x. And that equals 1. So now I know that tan of 2x is minus 1 on root 3. So from my exact values, which you have to know, the angle is pi on 6. But in this case, it has to be negative. I missed that out because this one is negative. So I have to think, where is tan negative? Well, tan's negative here and here. And I need to do 2 laps, or I can think 2x is between 0 and 4 pi. So that's now I know I have to keep going around to 4 pi. So what do I get? I get 2x is, well, the first one here is going to be at nearly 6 pi on 6. It's at 5 pi on 6. And this angle here is pi on 6. This one's nearly at 2 pi, or nearly at 12 pi on 6. And it's pi on 6 less than that, so it's 11 pi on 6. And then I have to do another lap around, so I'm going to get 17 pi on 6, because this is the same as 18 pi on 6. And then the last one, when this is 24 pi on 6, I'm going to go pi on 6 less, which is 23 pi on 6. It's a lot of fractions, isn't it? So x is 5 pi on 12, 11 pi on 12, 17 pi on 12, and 23 pi on 12. And in the next short video, I'm just going to show you how to do that on your calculator, which is way easier and way more fun. But while we're here, I'm going to keep going. And I'm going to have a look at these exam questions on the next page, just so I don't have to start again. It's the same technique. I reckon it's a good idea to have a go and just see how when it's an exam question, it's the same concept, but it's often just a little bit twisted. It's got a little bit of a quirk to it. So if we've got where point of intersection, that's where they meet. So that's where cos x equals a sine x. So what I'm going to do is divide each side by cos x. And you're going to see my messages. So we're going to get 1 on a equals tan x. So what's tan x? It meets at pi on 3. So 1 on a is equal to the tan of pi on 3, because that's where they meet. So the tan of pi on 3 I know is root 3. So that means a is 1 on root 3. So 2-mark question. You get 1 mark for doing something to recognise that it's tan, and 1 mark for getting that actual answer. And then the second one says, if x is between 0 and 2 pi, find the x coordinate of the other point of intersection. So between 0 and 2 pi, the first point of intersection where tan was positive was here. The next one's going to be here. So I know that my base angle is pi on 3, because that's the first point of intersection. So the next one here is just after 3 pi on 3. So that's at 4 pi on 3.